We are now going to take a look at the binomial theorem. You have almost certainly seen this binomial theorem. Very simple, straightforward one where you have a binomial or two terms, plus or minus in the middle, doesn't matter, they're the same, squared. Very simple. Of course, it could have variables, it could have values in it. And what you'll notice here is this is 1a squared, 2ab, and 1b squared. Okay, that's the second row, the second power. We'll come back to this Pascal's triangle in a second. What we want to do is expand it now beyond just squaring something. And you'll remember that this 2 is found because if you FOIL this out, you'll get, FOIL being a very kind of specific way of doing this, first, outer, inner, last. You had the outer and the inner terms being multiplied and ended up being AB, BA, or the same thing. And you had 2 of those. And if we end up doing higher powers, you'd get more combinations, which is why the counting principles we looked at come back into play. This Pascal's triangle helps form these initial coefficients where if you didn't have any other numbers in your binomial, would be the coefficients of more terms. So 6 choose 4 would be, looking at counting principles, the number of different ways if we had six different things that we could choose 4 of them, or similarly choose 2 of them, because you're excluding 2 and 4 in different groups. Essentially, it doesn't matter if you choose the 4 or choose the 2, which is why we get the symmetry coming through Pascal's triangle. So these are the coefficients that will come into the expansion of higher ordered binomials. They are also the choosing numbers that if you had 5 objects and you wanted to choose 3 of them, 0, 1, 2, 3, you would have 10 different ways. You can get them using the formula we've seen below, and you can also get these, should you want to write out all of them, by adding in the boxes above it. So like 1 plus 3 is 4, or 4 plus 6 is 10. So lots of different ways to come up with it. You do see it in many different ways. One thing that you need to note is we start at 0th row and the 0th column. So the 6th row, for example, if you had something to the 6th, because of that 0, would have 7 different terms. 1, 2, 3, 4, 5, 6, 7. Because of the 0, there's always one more. Squaring something gives you 3 terms, for example. So do keep this 0 in mind. It could affect things going forward as you do some problems. Here is the very messy expansion, the formula using the binomial theorem. I'm not going to dwell on this too long. I think it's a little bit easier to see once you look at an example. When you have any binomial, though, you're adding up a bunch of things. And those things are formed by having this is another notation of you have n objects and you're choosing r of them. That's the exact same thing that we already looked at. Your first term to some exponent and your second term to some exponent, where those exponents add to n, the original. That's, of course, before you have to deal with any exponents that might be inside your binomial. It ends up being one more term than the power, and they may simplify so that they don't have all of those little pieces right there. Here's an example just to the 5th, and you'll see how messy this gets quickly. Using the binomial theorem, you wouldn't want to expand this out by saying, okay, 2x minus y times 2x minus y, do that, do it again, do it again, do it again. Absolutely not any fun. But when you do this and you realize that these come in to 6 terms with kind of 3 pieces to each, you'll see why you often don't do all of this out. The IB may ask for something specific. So if you did have that formula, you would see that you have 3 pieces in each. And I will just start. We have 5 things and we want to choose 0. So this is the binomial coefficient. I will explain it in a second. You always have your first term to some power and your second term. Here it's a minus to some power. And those powers, we're just going to start, doesn't matter due to the symmetry, at 5 and 0. They will always add up to this exponent here. Each term is going to have your binomial coefficient, the NCR, the first term, and the second term, both the sum power. I'm going to add in the powers in just a second so you can see the pattern, but for now I'm just going to fill in these little pieces. That's only 3 terms already. Okay, 4, 5, choose 4 now. to some power to some power, and the last term fits in perfectly. 5 choose 5. These binomial coefficients are going to be symmetrical. And then the pattern we're going to see as we assign exponents here, I'm starting at 5 on this first one, 4, 3, 2, 1, 0, and the other way, 0, 1, 2, 3, 4, 5. There we go. Now you can see it, and they always add up to the 5. And now we just simplify. These chooses, you could use the formula. They are just, though, if I look at Pascal's triangle from before, that's this 5th row, again, starting at the 0, 1, 5, 10, 10, 5, 1. So if I have 5 objects and I want to choose 0, there's only one way to do that. Same thing here. The only way to choose one object, there are 5 different ways to do that. I'll just put that in parentheses because I wrote it. 10, 10, 5, 1. So there's symmetry in the coefficients. And now we're going to expand this. Don't forget that you do the power to all of it. So 2 to the 5th is going to be 32. X to the 5th, anything to the 0 is 1. Okay, 5 times 16, x to the 4th, times negative y to the 1st, 10, 8x cubed. Just be very careful about what will become negative, what's going to stay, or become positive, what will stay negative, and use parentheses as needed. 4x squared, like this cubed is still going to be a negative y cubed. 5 times 2x to the 1st, this will now be positive y to the 4th, times 1. And now we're just going to simplify this. So 32 x to the 5th, that minus is going to turn it into a negative. 5 times 16, so 80 x to the 4th. This is going to be another 80 x cubed y squared. Oops, I forgot my y here. 40, this is going to now be minus 40 x squared y cubed plus 10x y to the 4th minus y to the 5th. If you do have negatives, you'll see a pattern of swapping every other sign. And that would be fully simplified. You can't combine these terms because they don't have the same variables with the same exponents. So that would be a full expansion here. And you see it is quite long, but it would be way worse to have to do it over and over again. Usually they will ask you to find a specific term so that you don't have to work through all of that. This one is a little bit vague because what is the 6th term? Which way do we start in? They'll usually say something like find the term that has x to the 5th in it, or the constant term, which we'll see in a second as well, or they'll say in this format. But here's an example of what this could look like. Find the 6th term of this binomial to the 9th. Remember that each term is going to have your binomial coefficient, the first term to something, and the second term to something. That's going to be made up of 3 factors. So I'm going to come back to what that will look like. The first term to something, not forgetting negatives, and the second term to something. These exponents will need to add up to 9. I'm going to also put one of them there because of the symmetrical nature. It doesn't matter which. The 6th term, don't forget the 0. So the first term would be to the 0, 1, 2, 3, 4, 5. The 6th term. Did I count that right? 1, excuse me. To the 0, to the 1, to the 2, to the 3, to the 4, to the 5. Okay, that's the 6th term is going to be to the 5th because the original one is to the 0. There. I do want those to add up to 9. It doesn't matter what I pick here. I don't have the 9th row of the binomial coefficients written out, so I'll just use this. Although in a second you'll see I'm going to use my calculator anyway. 16y to the 4th. Actually, I used my calculator already, so it doesn't really matter. That became positive because of the 4th. These will cancel out in many ways, x to the 5th divided by x to the 4th. Okay, and when you simplify this, you could do it by hand relatively easily. 9 factorial is 9 times 8 times 7 times 6 times 5 factorial, so those would cancel. That 4 could cancel with part of the 8, the 6 with the 3 and 2. So it's not a terrible kind of arithmetic. And then times 16. And what you will get when you multiply all those coefficients is 2016. We'll just have a singular x because those cancel y to the 4th. So this would be the sixth term if we were counting in a certain order. And again, usually they'll be a little bit more specific, but you don't need to find everything. And usually they won't ask you to. It's just a waste of time. Here, for example, is how they may be a little bit more clear. You may sometimes see this as like a negative exponent, so don't get scared if you see negative exponents inside of your binomial. It works a very similar way. Find the constant in this expansion. Remember that a constant has no variables. It's just a number. Very common question. You will need to have a variable in the numerator and the denominator that cancel out. So this singular term is made up of these three factors. 15, choose something. We're going to need to pick cleverly. 3x to the squared, 3x squared to something, and negative 1x to something. So I need to split up these 15 so that when I apply my power laws here, they end up canceling out. And in this case, I'm going to need 5 and 10. 5 and 10 is 15. And what will happen is that this x squared to the 5th is going to be x to the 10th in the numerator. And this is going to be x to the 10th in the denominator. And the x's will cancel. Due to the symmetry, 5 or 10 is fine. And then you'll just want to put this into your calculator. I can write it out. I'm not going to, you could either keep it in this format or write it like this or leave NCR. 3 to the 5th is going to be 243. I'm not going to, of course, be able to put the x's into my calculator. This will become positive. 1 to the 10th is 1 over x to the 10th. Doesn't matter if you use parentheses or not. So as you put this into your calculator, you do have some options. The 1 is going to be silly. You could, just to show you again, say, okay, I just want 15, and then this choose is under probability. You could choose 5. You'll see that it's the same thing as 15, choose 10. You could also put in this. You could do the work and simplify it, but there's no reason to. So that's 3003 times 243. The x is canceled. So 3003, I should have just hit enter, times 243. So if you were to fully expand this, one of those terms would be this coefficient, 729,729. You may sometimes see these work backwards. You know that the constant is this. What is the power, for example, or what is the coefficient here? It's using these same ideas. You may need to set up an equation to solve it, but by and large, there's no new information, just perhaps applying it in different ways.